I can't tell you how excited I am actually that Southwest Ag and VERITAS is in the game on this issue, because it really does give us a chance to lead the way and come up with the answers. And let me tell you, we don't have all the answers. We think we have some potential for answers in this. But what we're really going to look at with this program is fertility, because I think fertility is a key. We've learned you can't grow crops without fertilizer. It's just the way that it works. Erosion, we can't ignore that. And so when you mention about going in with one pass in the spring with tillage for flea bane control, yeah, I get that. But as soon as you do that, you get the 4-inch rain. Now we have all that particulate matter moving, so it's still a big issue. I think there's other options. And then yield, because if you don't have yield, you don't work, right? Without economics, there is no such thing as sustainability. So what have we talked about? Again, you can't see that picture, but it is the algal bloom. And Phil, to your point, I particularly picked this one because you can't see it, but up there where Point Pelee is, there's a whole bunch of algae growing around Point Pelee. It's a Canadian problem too, from that perspective. So we have the phosphorus, we have the algae blooms. The other one that I can't emphasize enough, and we don't talk about, and you know that I'm Peter No-Till, so you know where I'm coming from. I'm a big reduced tillage guy. Every time you take one tillage pass out, you have benefited the soil, and you will be a longer-term farmer. This is a particular picture that I use quite a bit just to show tillage erosion. We all talk about wind erosion, and you guys on the sand that do tillage, you know, there's been a few times this spring and a couple springs ago where we didn't have whiteouts from snow in Kent County. We had brownouts from soil that was blowing across roads, which was just as dangerous to traffic as the whiteouts we get in Huron County. So yes, wind erosion is real. Yes, water erosion is real, but tillage erosion on rolling land, not maybe on this flat land, but on rolling land, tillage erosion is 10 times worse than soil and water erosion combined. So this is really a big thing. We can't continue down the tillage road. We have to find a better solution. And then we talk about fertilizers. Not showing up very well, but that's a wheat field. And the only place the wheat survived is over the corn rows from 2 years ago. It's the corn row syndrome to the extreme. So we know we need fertilizer, and this means most of my slides won't show up perfectly, but you know, I talk lots about phosphorus on wheat. That's a particular test that was on sand soil last year. There's a 30 bushel per acre yield advantage. We don't always get 30 bushels, but on average we get 7. It just shows you that we have to have that fertility in the mix. It's a must, right? So this is the other one, and that's really too bad. So the other thing that we're doing, and I think fits incredibly important in this discussion, is we are back looking at, do the OMAF fertility recs make sense? Because we've always done this sufficiency approach, where you can have a low soil test for phosphorus, a low soil test for potash, and if you do everything right, you can still get maximum yield. And we weren't sure that was true, so we started these long-term P&K trials, and you can't see it. This is Dave Hooker's work at Ridgetown. It's really unfortunate, but Marin's right, that pointer, even though it works, it doesn't show up on the screen. There's virtually no winter survival on this one, I think. Anyway, what we're doing on this particular one, what we're looking at is building soil fertility levels. And on these treatments, what really astounds me is, even though, you know, I am the poster child for seed-placed phosphorus on wheat, right? Everybody knows that I push that, I push that, I push that. If you don't use 100 pounds of MAP through your wheat drill, you're not a real wheat farmer. You're never going to break 140 bushels. Get over it. Don't call me. Just learn how to do it right. Meanwhile, in these trials at Ridgetown last year, we're building up strips of high fertility. And we have other strips where we're not building it up, and across those strips, we put the seed placed. And most of the time, the seed placed will do the job. At Ridgetown last year, where we planted extremely late, seed placed couldn't carry the load. So where we had our fertility, up here with less than 10 phosphorus and less than 80 potash, we have essentially no winter survival on the wheat, regardless of what we did with seed placed starter. I could not make it up. Where we only broadcast potash, which really astounds me because I don't think potash matters on wheat. Where we only broadcast the potash, we didn't do the phosphorus, I still had better winter survival. Even with low phosphorus soil tests, the potash made a difference. Inherent fertility made a difference. And that's a really intriguing result. And then you can almost see that, not quite, but you can almost see that. Here again, we have the no broadcast. Over here, where we broadcast both the phosphorus and the potash, perfect. Where we got our soil test levels above 25 for phosphorus, and that should say above, not below. Sorry, the phosphorus is above 25. I got my greater than and less than signs confused there, Tom. My apologies. Anyway, the soil test is above 25 and above 120. We had perfect winter survival. So I just think this drives home the point that we got to have decent soil fertility levels. So when we look at that, it really then comes down to this whole nutrient removal concept. And we can go through nutrient removal. You all know that it's based on yield. And all you have to do is take your yield and multiply it by the amount per bushel, and you can figure out what the removal is. And this is where I started with this concept that we have to change. If you're still doing the same fertility program that you did or your dad did 20 years ago, you're out of the game. Because 20 years ago, this is sort of the game that we were in. We had removal in a 3-crop rotation of about 132 and 124, and a couple hundred pounds of fertilizer every year would easily make that work. Nowadays, if we start looking at much higher yields, we all of a sudden change the process. So we now get up into the 200 bushel corn in this part of the world, right? You might get to 70 bushel beans. 110 bushel wheat is a poor wheat crop in Kent County, right? Not quite, anyway. But what's really intriguing is look at how these numbers have changed. So now our removal over that 3-crop rotation is 200 pounds per acre. So we're removing over that 3-year rotation 200 pounds per acre. So now I put on my environmental hat, my agronomist hat, and I say, how are we going to do that? Well, you know, when we look at that, that's actual that I removed, the 205 pounds. It works out to 394 pounds of fertilizer that I have to apply over that 3 years. And now I got to figure out how to do that, and I have to figure out how to do it without broadcasting the fertilizer, because I don't want to be like the Maumee River. I don't want to broadcast my phosphorus and have it move with the water into whatever river is going out into Lake Erie. And that's a tougher gig. So if I look at 394 pounds per acre of phosphorus that I have to do over that 3 years, and I think about it from an agronomic standpoint, I can do 100 pounds with wheat. Right? That's a done deal. 100 pounds of product with my wheat crop. I've already told you that's the way you got to grow wheat. I can do 94 pounds with my corn. Maybe. I put 94 as opposed to 100 because it had to add up to 394. Plus, I need some potash with my corn because remember that corn responds to potash in the starter. So I can't run only phosphorus, and I don't want to slow the corn planter down too much, so I think even 94 pounds for a lot of growers is pretty on the edge. Can we get there or not? And then I got 200 pounds that in order to make that work, I have to apply that other 200 pounds of phosphorus MAP just to balance my removal. And when do I do that? And that's really become the big question. And I think with this strip till opportunity, a whole bunch of things now come together. Because now, after the wheat comes off, if you take soybean or wheat out of this rotation, it just gets much tougher to do. But we can do it in a corn-soybean rotation. As soon as the soybeans come off, I go out there and I'm going to put that fertilizer through the strip tiller, and I'm going to put it in the soil, And the strip tiller is going to break up the macropores, so hopefully we don't get the macropore flow to the tile. It's under the soil, it's not moving across the surface. If I do it after wheat, I have that 3 months Ken talked about for the phosphorus to react a little bit with the soil, so that it's maybe not quite as available in March for that water to move it down through. So I think it gives us the opportunity to actually apply our fertilizer at removal rates and do it with an environmental conscience. Do I know that? The answer is absolutely not. This is the big reason that I teamed up with VERITAS, and I'm really excited, is that we now have this research project. It's called Project Strip Till. The Soil Warrior is available if you're interested. You need to see Dave, you need to see Aaron, you need to talk to me or Rick, whoever. We are going to go out on 10 fields in Ontario, and we are going to study them to death. And hopefully Marin will be involved with some, Dave Hooker might be involved with some, but we're going to figure this thing out, and we're going to find ways that you can still be the 240 bushel per acre corn grower, and you can replace that phosphorus, and the lake won't go green, so my sister can still go swimming and not beat me up every time I see her on the weekend over the summer. So I'm really excited about this. I think it's an awesome project. If you're interested at all, please join in, because at the end of the day, we simply cannot be like this. We just can't miss, right? We just can't miss. So, thank you very much for your attention. I'm going to turn it over to Dave, and Dave is going to tell us about the strip till unit and what's going to happen out there. We are going to have a demonstration if you can hang around for that, but we're just about exactly right on time. And very good. Thanks for turning out, and hopefully you can stay and see what's going on.